In high voltage engineering, this is the most important and very interesting topic, that is the voltage doubler and voltage multiplier circuit. Previously we know that how to step up the AC voltage by using the transformer. Yes or no? Some voltage is given to you, AC voltage, you can step up it to a higher value to the same AC voltage. But today we will come to know, through this topic you can come to know that how we will just make the conversion from AC to DC voltage, along with that with the higher magnitude. Means just the double of the input voltage, along with that some multiple of the input voltage whatever we are feeding at the primary side. Okay, so these are our main objective is generation of very high DC voltage from AC voltage by using the voltage doubler circuit, and our second thing is generation of a very high DC output voltage of n cross 100 volts from a source of 100 sin omega t AC voltage by using the voltage multiplier circuit. So what we will do here, we will use the two methods or two types of circuit. One is the voltage doubler circuit, another is the voltage multiplier circuit. In these two cases objective is same. In the first case we will just make the conversion from AC to DC with some higher magnitude, that is just the double of the input voltage. In the second case what we will do, we will not make the double of the input voltage, we will make some n times multiple of the input voltage, input maximum voltage. Clear? So first of all we will go for the voltage doubler circuit, how it is working, okay, and what is it, whether which elements it contains, like your capacitor, diodes, transformer or AC voltage, how you are feeding, what is the manner, how it is working. All these things we will discuss for the voltage doubler circuit. Then after we will come for the voltage multiplier circuit. Clear? Okay. So this is today we will discuss the two types of voltage doubler circuit. This is the first one type of voltage doubler circuit. Here how it is making the double of the input voltage, we will just see from the working. First of all, here we have connected one transformer. Through the transformer, this is one type of bridge combination of the diode D1, capacitor C1, C2 and diode D2. Clear? So first of all, as we are providing the AC input voltage, definitely we will have the positive half cycle work and the negative half cycle work. First come for the positive half cycle. What is happening? In positive half cycle, this terminal here we will have the positive, here we will have the negative. Yes or no? So whenever it is positive, it is negative. For that reason, this diode will be of forward biased and this bottom diode will be of reverse bias, and the connection, the current will flow in this direction. Okay, the current will flow in this direction. So what will happen, the energy from this side will flow through this diode and it will charge this first capacitor. Clear? So in the first half cycle the capacitor C1 is completely charged. Clear? This much is the working of the first half cycle. Second is in the second half cycle, that is the negative half cycle, what will happen, this will be your negative, this is your positive, accordingly just the reverse case will happen, this will be your reverse bias, this will be your forward biased. Okay, and the current will flow like this. Okay, as per the arrow mark the current will flow, and here through that this capacitor will be completely charged in the negative half cycle. Previously we are having this capacitor charged completely, now we are having this capacitor charged completely. So what is that, whatever the Vmax we are providing here, this Vmax is available two times here through these two capacitors. Clear? Vmax we are providing here, so here you are getting one Vmax, here we are getting second Vmax. So whenever you are taking the output across these two terminal, definitely you will get the two Vmax. Okay, in that way we can making the double of the input voltage whatever we are providing. Clear? Exactly, this is the total theoretical thing, but whenever it comes to the practical case, exactly 2 Vmax we are not getting due to some voltage ripple or some voltage drop. We'll discuss these things later, but it is providing you as the theoretical, it is providing you the more than the input voltage whatever we are providing. It is little bit less than the 2 V max. Okay. Next we will come for the second voltage doubler circuit. Here we are already acquainted with this type of circuit. Why? Because we know that whatever the half wave rectifier we are using, in that half wave rectifier it is only little bit modification. The diode is connected here, capacitor is connected here. We have just made the interchange in these two to have this type of miracle, because in this case we want to make the double of the circuit. Whenever we are just interchanging these two cases, in case of half wave rectifier, this is connected here, this is connected here. Now we have just interchanged and it is converted to the voltage doubler circuit. Here also we will come for positive half cycle as well as the negative half cycle. So this is the sinusoidal voltage you are getting here. Now come for, already we have discussed for the positive half cycle. Now just start from the negative half cycle. Okay. Whenever we are providing the negative half cycle for this one, then how it is working. You see here, in case of negative half cycle, this will be your negative, this will be your positive, and this capacitor here, this capacitor will be charged through this forward biased diode. Okay, and the current will flow in this direction like this, and this diode will be reverse biased. Okay, no current will flow through this one, only this circuit will work, and through that this capacitor will be fully charged. Clear? This is all about the second negative half cycle. Next come for the positive half cycle. In case of positive half cycle, for the same circuit, here as we know that the potential Vmax is available here in this capacitor. Again the potential of this coil is of Vmax as we are providing the AC input voltage. So what will happen? Whenever we are giving the positive half cycle, at that time this will be reverse biased, this will be your forward biased, and the current will flow in this direction. Okay, and it will charge this capacitor through this diode. So what will happen? The total charge, cumulative charge means this charge, okay, Vmax from here and Vmax from here, collectively will be available across this capacitor. Got the point? Whatever the Vmax we are providing from here, that Vmax in 2 times is provided to this circuit. So we will get just the double of this here, Vmax and another Vmax from here as well as from here. These two will be available in this capacitor. So here also we can get the 2 Vmax. Whenever we are providing Vmax here, at the output circuit we are getting the 2 Vmax. Okay. So this is all about the second voltage doubler circuit. But whenever we want something more than the double value, okay, suppose n multiple of the double value, we do not want, suppose we are giving here 100 volt, okay, Vmax is your 100 volt, we want suppose 300, we want suppose 400, 500, 600, then how you will manage that, how you will generate that high DC voltage? We will just see that. And this is can be explained through the voltage multiplier circuit. Okay. So our objective is very much clear here. Objective is we have to generate a very high DC voltage from a normal AC voltage, that is your, we can take it as the 100 sin omega t AC voltage by using this multiplier circuit. Okay, two things it will do. First one is it will convert from AC to DC. Along with that, whatever the DC you will get, that is the n multiple of that AC voltage. Okay, and here n is the integer, depends upon the number of stages you are adding to that voltage multiplier circuit. Depending upon your requirement, you will add the number of stages in that, so that finally you will get same multiple of that particular AC input voltage. Clear? Now come for this circuit diagram of the voltage multiplier circuit, our main given thing is the SC 100 sin omega t. Okay, we will just take that. We will make again same type of capacitor and the diode combination in such a manner that we will not get the voltage doubler, we will get the voltage multiplier value. Okay, let us come for drawing that circuit diagram. So here we are having the SC, that is the 100 sin omega t, and here just make a connection of the capacitor. Then with that capacitor, to charge this capacitor, let us have a diode with us. Okay, up to this much let us consider. Here we want to charge this capacitor through this diode. Clear? So this diode is charged, and across these two terminals, how much voltage we will get here? Here we are providing 100 sin omega t, and to this V max 100 volt, this capacitor will be completely charged. So this is your 100 volt, this is your 100 volt. So across these two terminals we will get such a voltage which is more than 0 volt. Okay, its maximum voltage is 200 volt, means across these two terminals you will never get a voltage less than 0, because whenever it come in the reverse direction, it will oppose the connection of the diode in this manner, will oppose the voltage to fall from 0. Okay, so the across these two terminals we can get a voltage which is more than, here this value is 200 and this value is 0 volt. Clear? Again we want something more voltage. For that reason what we have to do, here let us connect another capacitor. Okay, so here, okay, keep it here. Now this here we have connected another diode and another capacitor. Now the current will flow like this. Here the current will flow like this. This capacitor is completely charged to 100 volt. Okay, here we are providing 100 sin omega t, and the current will flow like this. So what will happen? This capacitor will be charged to a value of 200 volts. Why? Because we know that across these two terminals we are getting the 200 volt. Yes or no? Across these two terminals we are getting 200 volt. So definitely this capacitor will be charged to a value of 200 volt through this diode. Clear? So we can say that it is one stage only. Whenever we will come for the next stage, by in the same manner adding the capacitor as well as the diode combination, we will also get some more value of the voltage. Same here we have to again put one capacitor. Here you see second capacitor, here we have connected, second diode combination also we have connected. Like this we can proceed. Here also what will happen, whatever the voltage will be available here, whenever we are coming from here to up to this much, then this voltage will oppose this voltage. So definitely what will happen, this voltage 200 volt and this voltage, they will have the subtraction. So 100 volt you will get in this direction, and this is your 100 sin omega t. So finally what will happen, this will be at the lower potential and this will be at the higher potential, because it is of 200 volt in this direction, you will get the 100 volt. Clear? So what will happen, this diode will be reverse biased and this diode will work during this connection. Okay, during this connection this diode will work like this. So again some multiple of the voltage that is the 200 volt again will be available here. Clear? Similarly, this process whenever we will continue, again here also you will get 200 volt. Now we can have the more circuit, connect another capacitor here. Here let's come for one diode, and like this it is quite easier because simultaneously in the same direction we can have the diode connections. Like this, here you see in the same direction we can have the diode connections. Depending upon our stage, number of stages, we can just add the diode and the capacitor combinations. Clear? So here also again, here you will get the 200 volt in the same manner. Okay? Here also you will get the 200 volt the same manner. Now just keep it here, and if we are making this terminal as ground, then what will happen from this terminal to this terminal? How much voltage we will get? 200 volt. From this terminal to this terminal we will get 400 volt. From this terminal to this terminal we will get 600 volt. Yes or no? Whenever we are making this as the ground. Whenever we are making this terminal as ground, then at that time from this terminal to this terminal we will get 100. From this to this we will get 300. From this to this we will get 500. So in the topmost value we will get the odd multiple of the voltage. In the bottom part we will get the even multiple of the voltage. Depending upon our requirement we can make that portion ground, and accordingly we can take the respective voltages. Okay? Accordingly you have to take that, because here you see, here this terminal we are not making ground, because here we can make the addition of the circuits, diode and the capacitor combination depending upon our requirement. So it will be better whenever we will start from this beginning, because if we are starting from this beginning, from here, then we can get the odd multiple as well as the even multiple here from this side. This side if you are making this ground, you will get the odd multiple. If you are making this as the ground, you will get the even multiple. If from that side if you will ground, then we may not get that. Always you will get the, from this side if you will make the ground, no problem. Here you will get the always even. In the bottom part as well as in the top part, you will get the even multiple. Suppose I want 500 volt. I cannot get that if I will make that side grounded. If I am making this side grounded, then definitely I will get the both even as well as the odd multiple, because in case of voltage doubler circuit you cannot get the odd multiple. Okay, suppose I want 500 volt. How I will get 500 volt from the voltage doubler circuit? I cannot get that. I can get 200, 400, 600, 800 like that. But this multiple circuit will give you both odd multiple as well as the even multiple of the voltage. Okay, so this is all about the voltage doubler and the voltage multiplier circuit. Here as I said, in case of the voltage doubler circuit you say, or in case of voltage multiplier circuit you say, in these two cases, in case of voltage doubler circuit, as our number of stages are very less, okay, in that case we will not have that much losses. But whenever we are talking about the voltage multiplier circuit, then in that case we can have the losses, because we are increasing the number of stages here. Those capacitor, due to those capacitances and those diodes, we can have the voltage drop. So exactly that multiple of the Vmax we cannot get. Okay, some value less than the Vmax, multiple of that we will get. This is most important. Listen here, this is most important, that as we are working over very high voltage, so definitely the normal capacitor we cannot use that. Whatever the capacitor we will use, that should have the very good quality. Whatever the diode we are using, that should have the very good quality diode we should use. We should not use any lossy capacitor. By default all the capacitors are lossy, but we have to have some better quality of the capacitor, because we will make use these things in the high voltage circuit. It should have the capacity to bear that much of voltage, the peak inverse voltage of those diodes, and all these things should have the better and higher value. Okay. Actually, no, not for 100 sin omega t. We cannot go for the particular capacitor. It does not depend upon the 100 sin omega t. It depends upon that how much voltage stage wise, how much voltage it will carry. It depends upon that value. Why? Because listen here, stage wise, whenever we will go for the calculation of the voltage ripple as well as the voltage drop calculation of this circuit to get that exactly how much voltage we will get at the output. In that calculation, we should know that stage wise we will have the changed capacitor value. Okay, definitely we will have the changed capacitor value. No, not diode, only the capacitor value. We should have some changed value depending upon the number of stages. From one stage to next stage, in the first stage what will be the value of the capacitor, in the second stage what will be the value of capacitor. Ideally what happens, ideally we take whatever capacitors we have connected, those capacitors ideally we take as the all value as same. But if you want the exact value of the voltage drop as well as the voltage ripple to be available, then or to be known to you, then in that case we can make stage wise change in the capacitor values. Clear? Because whatever the diode we have kept here, that diode will help in the conduction of the current. That is not doing some important work. Only it is making the forward bias and reverse bias condition, it is making the conduction as well as in blocking of that particular circuit. But main duty is of the capacitor. The capacity of that capacitor should be better. It should have the as we are using in the higher voltage DC voltage, definitely it should have the better quality.